Hi, everybody. We're going to continue this lesson on how to determine whether or not a function is linear or nonlinear, but just a quick review, okay? Last time we talked about we talked about graphs, how to determine if they were linear or nonlinear. Remember, linear means forming a line or a part of a line. And we also talked about how to determine whether or not a table represents a linear function. And this is where the idea of the rate of change came in. So the rate of change of the y's and the rate of the change of the x's being part of this ratio, right? And if the ratio or the rate of change remains constant all the way down the table or all the way across the table, then the table represents a linear function. So we're going to pick it up from here this time. And we're going to talk about how to determine if a function is linear based on a set of ordered pairs. And I think you're going to find that this is just another takeoff of how to determine if it's a table, right? Or if the table is a linear function. We're going to take our set of ordered pairs and we're going to put them in a table, okay? Remember, an ordered pair always goes x, y. So if we're entering ordered pairs on a table, in this case, x is 0, y is 20, and we're going to go across. X is 5 and y is 16, and then on the third one, x is 10 and y is 12, and on the fourth one, x is 20 and y is 4. Now, remember from the last video, the way we determine whether or not a table is linear or not is we find delta y and we find delta x, okay? So we're going to go, let's do the delta y's first. It's always good to start with those. So we go down 4, down 4, down 8. So negative 4, negative 4, negative 8. And then we find our delta x's. This one's going up by 5. This one's going up by 5. This one's going up by 10. All right, so what we need to do now is we need to turn our delta x and delta y's into a fraction. Remember the fraction delta y over delta x. So let's take a look. The first fraction would be negative 4 over positive 5. The second one, that's this one, would be negative 4 over positive 5. Remember, delta y always goes on the top. And on the last one, we have negative 8 over positive 10. Our job is to figure out whether or not these three fractions are all equivalent. And I gave you a hint last time. If you weren't good with fractions, you can always use a calculator and do the top divided by the bottom. And if it turns out they're all the same decimal, then we know that they're equivalent fractions. And if you did that, or if you just compared the fractions here, you would realize that, yes, all three of these fractions are equivalent fractions. So is the delta y over delta x, or the rate of change, constant? Yes, which means that this set of ordered pairs is a linear function. So again, if you've got ordered pairs, turn them into a table, and then find the rate of change, which is the fraction, see if it's constant. So the last thing we need to talk about is an equation. Like, how do you know by looking at an equation whether or not it represents a linear function? Okay, and so I'm going to give you a little bit of, it's kind of a step-by-step idea here. I'm going to show you what a linear function is and is not. Okay, so we're just going to read down this list 1 through 4. No variable can appear in the denominators. Okay, so when you have a linear function, there are no variables in the denominator of a fraction, but they can be in the numerator. Okay, so they can be in the numerator. Number 2, the variables cannot be multiplied together. So we can't have x times y anywhere, or y times x anywhere. We can't have that. That would not be a linear function. Number 3, no variable can have an exponent other than a 1 or a 0. All right, so we can't have no x squared, no x to the third, no x to the fourth, or so on and so forth. And lastly, number 4, we can't have any variables underneath any square roots. Remember, this is a square root, okay? So we're not allowed to have a variable underneath a square root. Now, I've made a little flow chart here for you to follow, okay? So you start at the top and the answer is either yes or no, and you follow along down the line, and it should help you determine whether or not it's linear or not. But let's take a look at some examples. Number one, so I'm over here, okay? Number one, y is equal to 1/2 x plus 2. Is that linear? Well, we don't have any variables in the denominator. X and y are not being multiplied together. We don't have any exponents greater than 1, and there's no square roots. So this one is a yes. It is a function, and it's linear. How about number 2? Ooh, right away, look at this. X cubed. Since we can't have an exponent greater than 1, this one is not linear. What about number 3? xy equals 9. Ooh, remember rule number 2. Variables cannot be multiplied together. So this is not a linear function. How about number 4? Y is equal to 5/x minus 4. Well, rule number 1 says no variables can be in the denominator of a fraction. So this is also a no. This is not linear. Number 5. It passes all of our rules. So yes, this is linear. And lastly, number 6. There's a square root. We have an x underneath the square root. This one is not a linear function. So just by inspection, we can tell whether or not the function or the equation is linear or not. You just have to think about those 4 things. We're going to stop here, and you're going to head back to our Schoology page and see what's coming next. I think I'm going to have you practice this for just a little bit. If you have any questions, please let me know.